All right, this example says a baseball is launched straight upward with a velocity of 24.8 meters per second. First thing we're going to do is we're going to list all the information we have for the horizontal direction and the vertical direction. So let's start with the horizontal. Horizontal, we got the acceleration is going to be 0 meters per second squared. It says it's launched straight upward, which means the initial velocity in the x direction is going to be 0. All right, so that is only vertical velocity. So let's go ahead and go with the vertical. The acceleration in the y direction is going to be negative 9.8 meters per second squared. Our initial velocity is only in the y direction, 24.8 meters per second. Okay, so it says it's launched straight upward. Let's see, how long does it take while it's in the air, the hang time? So it goes up and comes back down, which means its displacement is going to be equal to 0 meters by the time it comes back down. All right, so first off, that's actually the y direction. The y direction, displacement in the y direction is 0 meters because it goes up and comes back down. All right, so it starts and ends at the same height, so the total displacement in the y direction is 0. All right, so we got initial velocity in the y direction, we got acceleration in the y direction, and we have displacement in the y direction. We're looking for time, so time is our question mark. All right, so how long does it take? Let's go ahead. We got acceleration, initial velocity, displacement, and time. So the displacement is going to be equal to 1/2 times acceleration times time squared plus the initial velocity times time. Displacement is 0. That equals 1/2 times negative 9.8 times time squared plus the initial velocity, which is 24.8 times time. All right, so clean this up a little bit. We get that 0 is going to be equal to 1/2 of negative 9.8, so it's negative 4.9 t squared plus 24.8. All right, we could take this term to the other side. Oh, that's being multiplied by t. Forgot about that. Take this term to the other side. We get positive 4.9 t squared. That's going to be equal to what's left on this side, 24.8 times t. And you can see that one of these t's is going to cancel from this side and from that side. So then that leaves me with 4.9 t equals 24.8. Divide by 4.9, divide by 4.9, and we get that t is going to be equal to 24.8 divided by 4.9, 5.06. So 5.06 seconds. All right. How high will it go? How high? So we're talking about max height here. Now, when it comes to the max height is going to be going to have a velocity final of 0 meters per second. All right, so when it goes up, it gets to that top point, it's going to stop before it comes back down. So we know the acceleration, negative 9.8 meters per second squared. We know the initial velocity, 24.8 meters per second in the vertical direction. So we have the final velocity in the y direction is 0, and then we're looking for displacement in the y direction. That's how high it's going to go. All right, so with that being said, we got final velocity squared is going to be equal to the initial velocity squared plus 2 times acceleration times displacement. Final velocity is 0. That equals initial velocity, which is 24.8 squared plus 2 times negative 9.8 times delta y, the displacement in the y direction. All right, so clean this up a little bit. We get 0 is going to be equal to 24.8 squared, so 24.8 squared. That gives me 615.04. And then plus a negative, so that's minus 2 times negative 9.8, which is 19.6 delta y. Now again, do not subtract those two terms because this one's being multiplied by a variable. So we take this 615.04 to the other side, it becomes negative, and then we divide by negative 19.6. So again, we take this to the other side, becomes negative 615.04, and then we divide by that negative 19.6, and that leaves our displacement on this side. We go ahead and solve that. Negative 615.04 divided by negative 19.6, and we get 31.4 meters. That's the max height. Number 2, it says a soccer ball is kicked horizontally off of a cliff that has a height of 2.8 meters. So it's not a cliff, it's a ledge. So the height of the ledge 2.8 meters, and it's kicked horizontally. All right, so kicked horizontally off of this ledge. So we know the horizontal velocity, the initial velocity in the y direction, in the x direction, the initial velocity in the x direction is 18.5 meters per second. Now, since it's kicked horizontally, then that means in the y direction, the initial velocity in the y direction is going to be 0. We also know that the acceleration in the x direction is always going to be 0. And the acceleration in the y direction, that's going to be negative 9.8 meters per second squared. We know that the displacement in the vertical direction, displacement as it comes down to the ground, is going to be 2.8, but it's downward, so it's going to be negative 2.8. All right. So how long is it in the air? How long is it in the air? So we're looking for time. And you can see we have all the information we need. We got displacement, acceleration, initial velocity. So finding the time. So the displacement is going to be equal to 1/2 times acceleration times time squared plus the initial velocity times time. So the displacement is negative 2.8. That equals half of negative 9.8 times time squared plus the initial velocity, which is 0, times time. Now keep in mind it's 0 in the y direction, that the horizontal has no effect on the vertical. All right, so that term actually goes away. Half of negative 9.8 is negative 4.9. So we take that negative 4.9 to the other side. So negative 2.8 divided by negative 4.9, that'll leave me with time squared on this side. So negative 2.8 divided by negative 4.9, that gives me that time squared is going to be equal to 0.5714. Then we square root both sides, square root this, and square root this, and we get that the time is going to be equal to 0.756 seconds. All right, so the next question is how far horizontally will the soccer ball travel before hitting the ground below the ledge? So this is looking for the range. Well, range is going to be looking in the horizontal direction. The horizontal direction, there's no acceleration. So we can use our constant motion equation, where velocity equals displacement divided by time. So the velocity is 18.5 in the x direction, 18.5. That's going to be equal to our range, or displacement, divided by time, which we just found to be 0.756. All right, so take this to the other side. It's going to be 18.5 times 0.756. That's going to be equal to our displacement. So our displacement is going to be equal to 18.5 times 0.756, and I get 13.99 meters, almost exactly 14 meters. All right. Part D, what's the final velocity in the vertical direction? Final velocity in the vertical direction. So we're looking for the final velocity in the y direction. All right. Well, again, we have enough information in our y direction in order to find that final velocity in the y direction. All right, so based on the initial velocity, the displacement, the acceleration, looking for the final velocity, then we get final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. Final velocity is what we're looking for. Final velocity squared is going to be equal to the initial velocity in the y direction, which is 0, squared, plus 2 times acceleration, negative 9.8, times delta y, which is the displacement in the y direction, negative 2.8. All right, so final velocity in the y direction squared is going to be equal to, go ahead and punch this all in your calculator, that's 0 squared plus 2 times negative 9.8 times negative 2.8, and I get 54.88. Square root both sides. Okay, so square root 54.88, and I get that my answer is 7.41. Now you got to be careful with this, because when you square root, you always get two answers. 7.41 meters per second. Now keep in mind, as we come down, the velocity is going to be downward, so that means that we're going to have a negative velocity, a negative 7.41 meters per second.